Hello, and welcome to Student Stress Review. This is Kevin, here with AP Calc, AB and BC, Unit 2, Differentiation. So let's look at the average and instantaneous rate of change. The average rate of change between 2 points is a slope formed by the secant line between the 2 points. And it can be given by the function f of b minus f of a over b minus a. While the instantaneous rate of change is the slope of this tangent line. So now defining the derivative. So the derivative is just the slope at a given point. And you can define it with the limit definition, which is the limit as h approaches 0 of f of x plus h minus f of x over h. And it can also be defined at a given point by using the limit as x approaches a of f of x minus f of a over x minus a. So the common notation used is f prime of x, y prime, and then dy dx. Now let's look at an example. So we have the function x squared, and this is the graph. We're trying to find what the derivative is, the general derivative. So plugging into the limit definition, you would do f of x plus h. So you do x plus h squared minus x squared over h. Now factoring this out, you'll get the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. As you can see, we have a common x squared on top, so we can eliminate those. We'd have 2xh plus h squared over h. You can see we have an h on the top and the bottom, so that would just leave us with the limit as h approaches 0, 2x plus h, and since h is approaching 0, the limit or the derivative would just be 2x. So if we wanted to say use it at point 2, like x equals 2, that means that the derivative would be f prime of 2, and it'll be 4. So saying that the slope of this line formed here, if this is point 2, is 4. So now let's estimate derivatives. So using a function, you just use the formula of a slope. So you would do like this, f of 3 minus f of 1 over 3 minus 1. And with these points here, it would be 6.1 minus 2.7 over 2. And then with a table, it's the same thing. You would just do f of 3 minus f of 1 over 3 minus 1, which you get 2 minus 0 over 2. So now let's look at differentiability and continuity. So if a function is differentiable, then it means that the function is also continuous. And if a function is continuous, it doesn't always imply differentiability. Two examples would be a cusp, so like the bottom point of an absolute value, or a straight vertical line. And this is because with the absolute value, the slopes, one is a -1, while the other is a +1. But meanwhile, with a vertical line, it'll be like division by 0, so it doesn't exist. So if a function is discontinuous, then it means it's not differentiable, yes. And also look at the power rule. So as you saw with this example up here, we had the x squared, how it became 2x. Well, this is just given by the power rule. So the derivative of a function of x to the n is just n x to the n minus 1. So now let's look at some examples over here. So we have x to the 7th. Well, that would just become 7x to the 6th. And here we have 5x to the 6th. What do? You just do 5 times 6, and then minus 1, so it'd be 5. And that would become 30x to the 5th. And the same rules apply for negative. So you just do negative 3, it'd be negative 9, x to the negative 4. And if we have like a square root, for instance, this would just be 2 times negative 1/2 x to the minus, and a half minus 1 would just be negative 3/2. You get negative x to the negative 3/2. So now let's look at some other derivative rules. So we have the derivative of a constant is always 0. And so when you take the derivative of like a polynomial, for instance, you can take the derivative of just each individual part. So with this example, you can just take the derivative of this, then this, then this. So doing that, using the power rule, you get 14x minus 4. The derivative of constant is just 0. So now let's look at some trig. So we have the derivative of sine of x is cosine x. And then the derivative of cosine x is negative sine x. And then we have the derivative of e to the x is just e to the x. Meanwhile, the derivative of ln x is 1 over x. Now these need to be memorized for the AP exam. Now we have the product rule. So the product rule is when you're multiplying two different functions together. So when you take the derivative, you would get f prime of x times g of x plus f of x times g prime of x. So using this example here, if you take the derivative, you'd have to do the derivative of this first part. So the derivative of 3x squared would be 6x. And then this g of x, you just leave it be, so it'd be e to the x. Plus, you have the f of x, so it'd be 3x squared. And then the derivative of e to the x is just e to the x. Now looking at this example over here, the derivative of cosine is negative sine. And you leave the second part, so you leave ln. And you leave the cosine be, so it'd be cosine x times the derivative of ln x, which is 1 over x. So now looking at the quotient rule. The quotient rule is when you're dividing a function by another. And it's given by g of x times the derivative of f of x minus f of x times the derivative of g of x over g of x squared. And an easy way to remember this is low d high minus high d low. So now using this function over here, let's take the derivative. So you would do the derivative of the top, which would be 7 times, you leave the bottom, so it'd be cosine x, minus the top, so it'd be 7x, times the derivative of the bottom, which would be negative sine x. Then you divide the whole thing by the bottom squared, so it'd be cosine squared x. So now let's look at the rest of trig and inverse trig. So we had the sine of x is equal to cosine x, and that cosine x is equal to negative sine x. Then we also have the derivative of tangent of x is equal to secant squared x. And then we have the derivative cosecant of x is equal to negative cosecant cotan x. And then the derivative of secant x is equal to secant x tan x. And then the derivative of cotangent of x is equal to negative cosecant squared x. So an easy thing to help remember these is knowing that cosecant and cotan go together. Meanwhile, secant and tan go together. That's just an easy way to help remember. Well, that's all for Unit 2. Thank you for being here. Hope to see you in Unit 3.